Algebra 2 students, we are going to continue our algebra unit with just a lot of building blocks and notation. First is interval notation. It uses 5 symbols. It uses brackets, or what I would call parentheses, square brackets, the infinity symbols, positive and negative, and the union symbol. The way it works is instead of writing x is greater than 3, what you could write is that 3 to positive infinity. If you look at it on a number line, you would have 3 here and an open circle pointing this way. If you had all the values on a number line between 2 and 5 with an open circle here and a closed circle here, interval notation would say go from 2 all the way up to 5, but the square bracket would imply that it equals. We will never include infinity, which will always have a parenthesis. The other parenthesis is because this can't be a 3, the parenthesis here because that can't be a 2. Sometimes you get things like this, from negative infinity up to 0, including it, and then you get something like from 1 to 3, and it might look like this. So in an interval notation, that would go from negative infinity to 0, including 0, never include the infinity. It also goes from 1 to 3, and then because it can be this and that, you do a little union. So that's what the union symbol is for. It's just a way of expressing sets of numbers that higher level mathematicians use. Take a look here. Use round brackets if the value is not included. A whole or an asymptote are examples of values that are not included. Oh, excuse me, we'll go back. Use square brackets if the value is part of the graph. So now looking at this graph, we're going to start talking about asymptotes, and right now we're just going to be talking about them as an idea. In this case, the line y equals 0 is a horizontal asymptote. This graph, y equals 1 over x, will get closer and closer to this without ever touching it. It also has what's called a vertical asymptote. The graph will get closer and closer to the vertical line x equals 0 without touching it. So when we talk about asymptotes and we relate this to domain and range, the domain are all values except 0. So the best way to write that is from negative infinity to 0, union from 0 to positive infinity. That's how you could talk about every value but 0. The range ends up being the same values, from negative infinity to 0, not including it, union from 0 to positive infinity. We are going to work on graphing functions and trying to find their domain and range from a graph. You will be able to find domain and range at the end of the year algebraically, but right now we're looking at a graph. So the y equals button on your calculator is how you graph. The window button is how you set the minimum and maximum of the values for x and y. And then the fifth button over to the right, graph, is how you actually have the calculator produce a graph. Tomorrow in class, we'll sit down and we'll go through some examples together. For now, something else to look at. Set builder notation. Just another way of expressing answers. So we have these braces to mean the set of. You have the less than or equal to, the greater than or the greater than or equal to symbols. And then you have this notation, is a member of the set of real numbers. That's just a way you would describe a domain of all real numbers. So set builder notation is just another way to write stuff down. So back to this example that we had earlier. Here's 3, it's bigger than that. You could say this is the set of all x such that x is greater than 3, close set. So this notation or this notation are acceptable, and you need to know the difference. Set builder versus interval notation. We will default to interval notation unless I otherwise state, but set builder notation is just another way to write it. Can be a little bit annoying. One they don't have here is not equals. So sometimes I'll do this, the set of all x such that x does not equal 0. That's a little lazy. Sometimes if it's all real numbers, it's x such that x is an element of the real number set. So real numbers, oh, that's a terrible bracket, I'm sorry, or brace, but there we go. So let's take a look at some other things we need to know here. I love this example. Negative 2 to positive infinity, x is greater than negative 2. You can write it this way. Negative infinity to 4, that means x is less than or equal to 4. You could write it in set builder notation this way. Between negative 3 and 3, including negative 3 but not 3, you could write it as a compound inequality. Here, from negative infinity to 5, and all the values from 6 up to positive infinity, you'd have to write two separate inequalities. I wouldn't mind if you wrote the word or in between there. And then from negative infinity to positive infinity, that would be x is all real numbers. I think that's it. Going pretty fast because I want to save your time and I got a pizza in the oven. So, gotta run. Hope you're doing well. Thanks for watching. Peace.